everyone, welcome to Physics by Aaryan. I am very happy to welcome you all in our free foundation physics course. So in this 15 days of free foundation physics, I am covering all the basic concepts that you will be needing for your physics competitive exams. Now we are moving to the next topic, which is rotational motion. I think the rotational motion is one of the most important topic of our foundational physics course, because this topic is asked directly in the exams. Either you talk about CSIR net, either you talk about GATE, JAM, JEST or TIFR. In all the exams, the rotational motion is asked directly. So we will cover this topic in great detail. We will not talk only the brief things. I have covered all other topics very briefly. But for rotational motion, I will be going little deeper. I will be going much more in depth, and we will cover rotational motion in 3 days. Each day you will get 2 lectures, and notes for each day will be available on our website and an app. Also, in the end of the rotational motion, there will be a quiz based on rotational motion, and also the PYQs will be available based on the rotational motion. So once the rotational motion is done, you can do the online quiz and online PYQs. So on our website and app, you can find the PYQs are divided topic wise for each exam. So for TIFR also, for JEST also, for JAM also, for GATE and NET also, the PYQs are divided topic wise. So you can actually take the PYQs topic wise in the form of online quiz. So I have made the quizzes for PYQs, that all the PYQs that has been asked in the previous year, I have made a quiz for that. So you can actually take that quiz after your rotational motion is done. In order to attempt these quizzes, you can join our website or our app. Okay, so let's move on. So rotational motion will have basically 3 parts. Number 1 is center of mass. What is center of mass? How do we calculate center of mass? Center of mass for a discrete body and a continuous body. Then how the center of mass moves. So what is a motion of center of mass? So this is our first segment. You should cover these 2 lectures in 1 day. Then we will move to second segment, which is collisions and moment of inertia. So in elastic collision, coefficient of restitution, many examples I have discussed in this lecture, and moment of inertia. Similarly, what is moment of inertia? When do we use moment of inertia? How do we calculate moment of inertia? All those concepts are there in the lecture. And in the last 2 lectures, we will be covering torque and application. So torque and application involves angular momentum, torque, the tau equals to I alpha, rotational equations of motion, and so on. So in these 2 lectures, I have covered all of that. So these 6 lectures combined will complete your rotational motion. We will not hurry up. Initially, I was planning to give only 4 lectures. According to the schedule, if you will see, there are only 4 lectures for rotational motion, but I have break down those lectures into 6 because I found out that rotational motion is much more important topic. So we should give a very good enough time to that, so that our actual syllabus also gets covered, because these topics are directly in our syllabus. So this is not something we are doing as a foundation, but these topics are actually in our syllabus. Okay, so let's start. So number 1 topic is center of mass. So what is center of mass? As you can see this person, is holding a plastic object or plastic bird on his finger. So he is balancing the bird on his finger. So the point where he is balancing this bird is known as center of mass or center of gravity. So we will talk about center of mass and center of gravity both, but right now you can understand where the entire mass of a body can be balanced. That point is known as center of mass. Okay, so you can balance any body at one point. You can balance a stick at one point. You can balance a sphere at one point. All those points, you can balance a disc at one point. So all those points, at the point where entire body can be balanced is known as center of mass. So center of mass is defined for many particle system or a continuous body. So let's say you have a system which has many particles. All those particles are discrete, means separated from each other, and there are many such particles. So you can define a center of mass for that body, or you can even define a center of mass for any continuous body. So any continuous body means a stick or a disc or a cylinder like this. Okay, I hope that you have got the concept. So now first thing we want to know is, how do we find the center of mass for a n discrete particles? So let's say there are n particles. The mass for each particle is m1, m2, m3 up to mn. So there are n particles, each having mass, some mass, and the coordinate of each particle is x1, y1. So mass 1 is at x1, y1. Mass 2 is at x2, y2. Mass n is at xn and yn. So we are asked to find the center of mass. So the formula for center of mass is summation of mi xi divided by mi, and the summation is for I. Okay, and your I goes from 1 to capital N because there are n particles. So your I goes from 1 to capital N. So if I expand this, what will I get? Mi xi means m1 x1. Summation means plus. You have to keep on adding. Plus m2 x2 plus so on up plus mn xn divided by m1 plus m2 plus mn, which is a total mass. So this m is nothing but your total mass, which is summation of mi means m1 plus m2 plus up to so on mn. So if we do that, that will be our xcom. Similarly, what is ycom? Center of mass. What is a y coordinate of center of mass? That is summation of mi y1 yi divided by total mass. So if we expand this, that will be m1 y1 plus m2 y2 so on mn yn divided by total mass. So total mass is nothing but just simply m1 plus m2 plus m1 plus mn so on. Okay. So let's understand this with an example. So you have 4 particles. So there are 4 particles, 1 kg, 2 kg, 3 kg and 4 kg. They are placed at the vertices of a square. So square is shown to you. So at A, 4 kg is there, at B, 3 kg is there, at C, 2 kg is there, and at D, 1 kg is there. If it is square, then we can assume that A point is center of mass. Oh, sorry, not center of mass, origin. So A point is origin, which means it is at 0, 0. If it is at origin and the side of the square is 1 meter, okay, so the square has a side of 1 meter, then the B will be at 1, 0. 1, 0 means it is along x, but y is 0. So in x it is 1 meter away, but in y it is 0. Similarly, C is 1 meter in x also and 1 meter in y also. So the coordinate of C is 1, 1. And the coordinate of D is 0, 1. 0, 1 means it is 0 in x, but 1 in y. So we have written all the coordinates. So now we will find the center of mass. So what is our formula for center of mass? Xi mi by total mass. So Xi mi, so let's see first mass. First mass is A, which is 4 kg into x coordinate of A, which is 0, plus second mass is 3 kg and the x coordinate of second mass is 1. So I will multiply 1, plus third mass is 2 kg, multiply by the coordinate of C, which is 1. So I will write 1, plus last mass is 1 kg and its coordinate is x coordinate is 0. So 1 multiplied by 0 divided by total mass. So total mass is 4 plus 3 plus 2 plus 1. So let's solve this. You will get 0 plus 3 plus 2 plus 0 divided by 4 plus 3 7 by 10. So you will get 5 by 10, which is 0.5 meter. Now let's find similarly YSUM. So YSUM will be summation of mi yi divided by total mass, which we have already found is 10. So mi yi, so first mass into y coordinate of first. So y coordinate of first is 0. So 4 into 0 plus 3 into y coordinate of second. Y coordinate of second is 0. So again 0 plus 2 kg into the y coordinate of 2 kg, which is 1. So I will multiply 2 into 1 plus last mass, which is 1 kg into the y coordinate, which is also 1. So 1 into 1 divided by the total mass, which is 10. So if you solve this, you will get 4 into 0, 0, 0, 2 plus 1 divided by 10, which is 3 by 10, which is 0.3 meters. So your x center of mass is 0.5 and your y center of mass is 0.3. So let's locate this body here. So your x center of mass is 0.5. It means it is in the middle. So it is at middle. But your y center of mass is 0.3. So it is somewhere here. So this is your point. Okay. So this is your center of mass. So you can clearly see that your center of mass is close to the heavy side. So your lower side is heavier because lower side has 7 kg mass and upper side has 3 kg mass. So you can clearly see that your center of mass is closer to the heavy side. So always remember, whenever you have a body which has a non-uniform mass distribution, your center of mass is always close to the heavy side and it is away from the lighter side. Okay. Next, let's do one more question. So another question is, consider a two particle system. So there are two particles, mass m1 and mass m2. We are somehow assuming that mass m2 is bigger than m1, just to give you a physical picture. However, it does not matter. What assumption I make does not matter. I'm just making this assumption to give you some sort of physical feeling about the problem. So if m2 is greater than m1, then the center of mass will be close to m1. Oh, sorry, m2. I just mentioned that the center of mass is close to the heavier body, which means the center of mass will be close to m2 if I am assuming that m2 is greater than m1. So what happening now is, when you have a center of mass C, then what is going on is your center of mass, let's assume, is at distance x1 from m1 and it is at distance x2 from m2. Okay, so let's assume center of mass is origin. Let's assume this, and your m1 is at distance x1 away and your m2 is at distance x2 away. This is just my assumption, or this is just my something I'm taking to solve the problem. Okay, what will be the center of mass then? The center of mass will be m1 x1, but now not x1, it is minus x1. Okay, so if you see the position of m1, it will be minus x1 into 0, and if you see the position of m2, it will be x2 comma 0. So if I multiply m1 with minus x1, you will get minus m1 x1 plus m2 x2 divided by total mass, which is m1 plus m2. So this is your initial center of mass. Now what is going on? Now what happens is, if the particle is pushed, so here you can clearly see this line, if the particle is pushed towards the center of mass through a distance d, by what distance the second particle to be moved so as to keep the center of mass at the same position? So this is your question. So what happened is, he's saying that let's say I push this first mass by distance d towards the center of mass. So I pushed this mass m1 close to center of mass by distance d. Now by how much distance the second mass should move so that your center of mass remains same? Your center of mass does not change. So let's say if you move mass m1 by distance d, then I have to move mass m2 by d dash. And I need to find d dash in order to make sure that your center of mass remain same. Okay, so simply let's do it. So what is the new position of m1? The new position of m1 is x1 minus d. Okay, so the new position, so this total distance is x1 and you have moved d, so your new position is x1 minus d. So what I will write, m1 into x1 minus d, and I will put negative sign. Why? Because it is on the left side of origin. So whatever is on the left side of origin, we put a negative sign. Okay, similarly, what is your new coordinate of m2? That is x2 minus d. So this entire distance is x2 and this is d dash. So what will be your this much distance? This much distance will be x2 minus d dash. So m2 into x2 minus d dash divided by total mass, which is m1 plus m2. Now what is my requirement? My requirement is my center of mass should remain same. So if I want my center of mass to remain same, then what I will say? I will say x initial center of mass equals to x new center of mass. So I can just equate this equation and this equation. So if I equate these two equations and do some simple mathematics, then what I will find is that d dash is coming out to be m1 by m2 into d. Okay, so this is your form. So if the mass m1 moves by distance d, then the m2 has to move by distance d dash to make sure that your center of mass remains at the same position. Okay, so this is a very good question to have a very good understanding of the physical picture which is going on. Okay, now this was the center of mass for the discrete bodies. When I said that there are masses m1, m2, m3, all are separated from each other and they are quite away from each other, and coordinate for each mass is given, then how do you find the center of mass? But now I am asking, what will be the your center of mass for continuous mass distribution? So now you have continuous bodies, for example, cylinder, rod, so on. These kind of bodies. Then what will be the center of mass for these bodies? The formula for center of mass is xcum equals to, now the summation will be replaced by integral. So this formula is x dm integration divided by dm integration. Similarly, y cum will be y dm integration divided by y dm. Sorry, divided by dm integration. And similarly for z center of mass. So using this formula, you can use the continuous mass distribution, or you can find the center of mass for continuous mass distribution. Okay. So let's see with an example. The number one example which I want to discuss is uniform rod. So there is a rod which is one dimensional, and the length of the rod is capital N, and the total mass of the rod is M. So M is a total mass of the rod and L is a total length of the rod. And I want to find the center of mass. So in order to find center of mass, you know that xcum is x dm integration and divided by integration of dm. So the integration of dm is nothing but your total mass. Integration of dm will give you total mass. So what is dm? Dm is a mass of the small element. If you consider a very small element on a rod, the mass of that element will be dm. And if you integrate all such small elements, then you will get the total mass. So let's take a very small mass on a rod and then add all such small particles. Then what you will get is total mass. That is why the integration of dm is capital M, which is total mass. Okay. So now what we will do is we will assume that there is a small mass whose length is dx. What will be the mass of this small length? So the mass of this small length will be mass per unit length multiplied by the length you have taken. So this rod has mass per unit length m by L. So mass per unit length is m by L. And what will be your length? Whatever length you have taken, you have to multiply with that. Okay. So this will be your small mass dm. So dm is always, remember, dm is always, I would like to give you some formula for dm. Okay, so what is your dm? Dm is lambda dx, where what is lambda? Lambda is mass per unit length. Okay, so your mass per unit length is m by L and your length is dx. Okay, now let's use our formula. So our formula for center of mass is x dm. So x is x. What is dm? Dm we just calculated, it is m by L into dx divided by your total mass. Okay, now how do I solve this? So let's do it. So let's take m by L common, and there is one m in the denominator as well. So you will get x dx. What will be the limits of x? So your x is going from 0 to capital L. So your x is going from 0 to capital L. Let's solve this. So your mm will cancel out. So you will get 1 by L, and your x integration is x square by 2, which is going from 0 to L. So if you solve this, you get an answer of L by 2, which is very physically possible answer. Where if you want to balance this rod, where will the center of mass will be? It will be at the center, which means it is at L by 2. And this is the same result which we got. What about y center of mass and z center of mass? It will be 0. Why? Because the rod is along x-axis. It means the y and z of the rod is 0. So if you put y and z 0 here, so what is your y center of mass? Y center of mass is y dm integration, and if you put y 0, your answer is also 0. Similarly for z c1. So your y c1 and z c1 is 0, which is very probably very good answer, because we know if the rod is along x-axis, then the center of mass will also be along x-axis. Okay, so that is about the uniform rod. Now I want to extend the same logic for the non-uniform mass. Now your rod does not have the same mass throughout, but your rod has a non-uniform mass, means somewhere mass is more. Let's say here mass is less, but here mass is more, and here mass is even more. So your rod is non-uniform. And what is mass per unit length given to you? Mass per unit length is given as 2 into x, kilogram per unit meter. Okay, so mass per unit length have a unit of kilogram per unit per meter. Okay. Now again the same same step we will repeat. Let's say we are taking a small element which has a length of dx. So what will be the mass of this small length? I just told you it will be lambda dx. So lambda is 2x and dx is dx. Now let's use the formula of xcom, which is x dm divided by total mass. So let's first find x dm. So x dm will be, let's put a value of x as x. And what is dm? Dm is 2x into dx. 2x into dx. So you will have 2 into x squared dx, and your x is going from 0 to capital L. So what will be that? You will get an answer of x L cube by 3, which is 2 by 3 L cube. So this is your x dm. Now let's find the total mass. Total mass is summation of dm. What is dm? Lambda dx. And what is lambda? Lambda is 2x dx, and your x is going from 0 to L. It means your answer is L square by 2, which means your answer is L square. Okay, so this is your total mass. So now what is your center of mass? X dm divided by total mass. So x dm is 2 by 3 L cube, and your total mass is L square. It means your answer is 2 by 3 times L. So this is your x center of mass. And you know that since the body is along x-axis, then your y-com and z-com will be 0. So this is how you solve a non-uniform rod problem, or any non-uniform problem you can easily solve like this. Okay, I hope that you have understood this. If you have any questions, please feel free to connect with me on any platform. You can connect with me on a Telegram. You can connect with me on a comment section. You can either message me as well. I am always available for the students, and please let me know if you have any doubt. Or if you feel that I have done any step wrong, you can correct me, because I am also a person, I can make mistakes. Okay. Now let's move to the next part of the topic, which is symmetric bodies. Whenever you have a symmetric bodies, for example, square, rectangle, triangle, or a disc, the center of mass is always at the center. So it is always at the center. So this is the concept that you should remember, and you can even physically imagine this. If I ask you to balance let's say a square, then where will you balance? You will balance the square in the center. Same goes for rectangle, same for triangle, and same for disc. So nothing new here. You know this already. But using this concept, we will solve one problem which is very interesting. So let's see. So now you have a body, which you can think like one is square. Let me change the color of the pen so you can see. So one is square and one is rectangle. So this, how do I solve this problem? How do I find the center of mass of this body? The total mass of this body is 3 kg. The total mass of this L-shaped body which you are seeing is 3 kg. And the dimensions of all the dimensions are given to you. How do I find the center of mass of this body? So what I will do is I will divide this problem into 2 parts. So first of all, I will find the center of mass of the 2 objects. So one is square. So where will the center of mass of square will be? So you can clearly see that center of mass of square is somewhere here. If I redraw this diagram, then my center of mass of this body will be at the center of the square, which is this point. Now, if you clearly see what is the x distance of this point, x distance of this point is this much, which is 1/2 of 1, which is half. Okay. Similarly, if you see what is the y distance of this point, then you can clearly see this is the y distance of this point, which means what is this one? 1 plus half, which is 3/2. So up to here it is 1 and up to here it is half. So 1 plus half will give you 3/2. So the position of this C2 point or the center of mass of square is half x coordinate and 3/2 y coordinate. Similarly, you can find the center of mass of your rectangle. So if you see that the x coordinate of this, how do you see what is the x coordinate of this body? That is this much, which is this entire thing is 2. So this is 1. And what about y? This entire thing is 1. So this is half. So your y coordinate of rectangle, your center of mass coordinate of rectangle is x is 1 and y is half. So now you can treat this body as a two bodies, as a two masses. So one is mass m2 and one is mass m1, and you know the coordinate of both. But you don't know the masses of both. But masses also we can find. So the total mass is 3 kg. The total mass is 3 kg. So this square will have 1/3 mass. Okay, because you can clearly see from the diagram that whatever the total mass is, this square will have 1/3 mass. So this square has m/3, and this rectangle will have 2/3 mass, which is m1 is 2/3 into m. So what is m? M is 3 kg. If you put m 3 kg, then your rectangle has a mass of 2 kg, and then your square has a mass of 1 kg. Simple. Now you have two masses and the coordinate. So what will be xc1? Xc1 will be mass 1, which is 2 kg, and the x coordinate of mass 1, which is 1, plus then second mass 1 kg into x coordinate of second mass, which is half, divided by total mass, which is 3. So if you solve this, what is an answer that you will get? 2 plus half divided by 3, which is 5/6. Okay, I hope that you understood this concept, that the mass will be 5/6. There is no doubt in this, and very simple question. You can actually find this very easily. Okay, now let's find YC1. How do you find YC1? Again, first mass, and what is the y coordinate of first mass? Half. So I will multiply with half, plus first mass, and what is the y coordinate of first mass? That is 3/2. Divided by total mass, which is 3. So if you solve it, you will get 1 plus 3/2/3. So this is again 5/6. So both are 5/6, 5/6. So this will be the center of mass of your this entire body. So initially it might seem difficult, but we can reduce these kind of problems into a simpler terms. Okay, very nice. Now let's move to the next part, which is carved out shape. So many times what happens is there is a body, entire body is given to you, and through that body, some of the mass is cut out. So how do we deal such problems? So there is one problem given in front of you. So there is one diagram. Okay. And in this diagram, what is happening here actually is you have cut down this much mass, and then you place this mass here. So there was a disc, there was this disc, and from the disc you cut this mass, and then you place this mass here. What will be the new center of mass of this body? Okay, let's do it. Let's try to solve this. So first, let's find the mass of this cutout portion. What is the mass of this cutout portion? So I will say that mass of this cutout portion is, what is the mass per unit area of your body? This is defined as sigma. Mass per unit area of your body is defined as sigma. So mass per unit area of the body will be, let's say this total mass of this disc was m. So let's say your disc has a total mass of m, and the disc has a total radius of r. Then the mass per unit length area of this disk will be m by pi r square. And what is an area of a body which you have taken? That is pi into r by 2 square, because the radius of your disk which you have cut down is r by 2. So your mass of this disk will be mass per unit area into the area which you have taken, which is pi r by 2 whole square. So if you solve this, the mass of this disk will be capital M by 4. So if the mass of entire disk is M, then the mass of this cutout portion will be M by 4. Then the concept comes into picture. The concept says, if you take out any piece, if you cut down any piece, then assume the mass of that cut out piece to be negative, because the presence of mass is positive, but the absence of mass means negative mass. If the mass is absent, it means you have a negative mass at that place. Okay, so that is a concept which we will use. So let's reduce this problem into a simpler problem. What is a simpler problem? So initially you had an entire disk. So disk was at complete disk. So if a disk is complete, where will its center of mass will be? It will be at the center. So I have given the center at entire mass of a disk at center. So instead of discussing entire disk, I have assumed that disk has a center of mass at center and the mass of the disk is m. Now I have cut down the portion, right? So I have cut down the disk from here. So I have cut down this disk. What will be the center of mass of this disk? It will be at its center. So the center of mass of this disk will be at the center of this disk. Okay, so at the center of the cutout portion. So what is the mass of this cutout portion? That is m, not m, it is minus m, because it is cut down. So I will say it is minus m. Now I have placed this body on this side. So here I have placed some mass. So I will say here I have a positive m. So what is the distance? So this distance is r by 2, not r by 2, since it is on negative side of origin. I will say minus r by 2. And what is this distance? This is positive r by 2. Now we have three bodies and we can easily find the center of mass. So how do we find the center of mass? So let's keep first body, which is minus m, and its coordinate, which is minus r by 2, plus capital M into 0, plus mass into its r by 2 divided by total mass. So total mass is minus m plus m plus m. So this will cancel out and your total mass will be remain as plus m. So you will get mr by 2 plus mr by 2. Okay, so you will get mr by 2 and mr by 2 plus, okay, divided by capital mass m. So you will get mr by capital M. What was the small m? Small m was capital M by 4. We already calculated this. So if I put values, I will get r by 4 as my center of mass. So my center of mass is r by 4. Okay. Now what about my y center of mass? My y center of mass will be at 0, because you can see all three bodies are along the x-axis. So there is no body along the y-axis. So my y center of mass will be 0 and my x center of mass will be r by 4. So this is a concept which I have used to solve the problem of cut down portion. If some part is cut out of the body, then how do you solve the problems? I hope that you have understood this. The last thing which I want to discuss, without derivations, you have to remember some formulas. That will make your life pretty easy in the questions, because many times these results are directly used. So let's say I give you some solid cone, and this cone is a solid and you have a uniform mass density. Then what will be the center of mass of this cone? It will be at the height 3h by 4 from the edge. So this is known as the vertex of a cone. From the vertex, your center of mass is at height of 3h by 4. Similarly, if you have a hollow cone, then the center of mass will be at 2h by 3 from the vertex. Now, what about the hemisphere? If the hemisphere is solid, then from the center of the base, your center of mass is 3r by 8 away. R is a radius. Okay, and if the sphere is hollow, then your center of mass is at distance r by 2 from the center of the base. Okay, then I think you can leave these two topics. these will not come directly in your exams. I don't think so you will be ever needing this. So you can ignore this. If you want to study, you can study by your own. I have given you the formula, but I don't think so you will be directly needing this. So the basic 4 results that you will be needing is hemisphere and cone. What is a result for solid hemisphere and what is a result for hollow hemisphere? So this was all about center of mass. In next class, what I will be discussing is how a center of mass moves. So if a body of many particles is moving, how we can reduce that motion into a motion of center of mass. So let's meet in the next class. I hope that you enjoyed this session. If you enjoyed this session, please let me know that you are having fun attending the lectures and have an open conversation with me. Okay, goodbye everyone. See you all.